to provide for you guys how to describe it. Yeah, can you go with the basics of freshman? Sure. Yeah. Just I only ask because like I know I personally don't like it when professors go over. Can you guys see the doodle? Do you guys see the whiteboard? Can you guys see me drawing? Okay, cool. I personally don't like it when professors, stuff that we know or should know. When professor goes too far into depth, I think it's boring. So I'm gonna keep it all very streamlined for you guys. Okay. So what are arrays? Arrays are a type of collection. They allow us to store stuff, store data of similar type in a collection. An array is what we call first in, first out, or FILO, or FIFO, first in, first out, because it operates in a queue system, meaning our first element goes here at the beginning, and then when we go unpack through it, we start from the beginning. But there's, this doesn't become as relevant until you get to data structures. For now, just know that you have an item. So let's suppose that this is a array of integers, okay? And I have 7, 8, 104, -5, and 0 in here, okay? So this is an array of 1, 2, 3, 4, 5, of size 5. And the way I refer to specific elements in this array are through their indices, which we start from numbering 0, 1, 2, 3, 4. So let's say through my work, I decide, I don't want it to be a 0 here. I want it to be a 2, okay? And then let's say we have an operation that anytime that there's an even number, it doubles it, right? So we loop through the array. We go, okay, index 0. Is this odd or even? It's even. It's odd. Okay, so we skip it. Odd or even? Oh, this is even. So we're going to double it. We're going to double the value because that's what our program does. This next one becomes 208. 208. This is odd. Oh, this one's even, and this one becomes 4. Cool. I can access, those are the indices. We can work with stuff specifically. I can say, let's suppose we have an array int. So the way you declare an array, similar to how you declare a variable, except you put these brackets here after it, saying that you're creating an array of this data type. Int array is what we'll call this, is equal to, there's a few ways you could initialize it. One, let's say we want to just have 1, 2, 3, 4. This is one way to do it. Another way to do it is to have maybe a new int array of size 5, let's say. I want 5 slots in there. Make this thing differently. And then I can put stuff in there by saying int array to index 1 is 3. So then what ends up happening is our array becomes null, 3, null, null, null. And the reason why I'm putting null, something important to keep in mind, null and 0 are not the same thing. Null is nothing. 0 is still a value. So newer versions of Java are sometimes smart enough to, instead of initializing these to null, they'll initialize them to 0. But it's good practice to assume it's going to be null, because you never know. You want to act like you don't know what environment. I should say. It's bad practice to assume that you're writing to a specific environment. It's better practice to assume that these are going to be null and work from that perspective. So like if I said, my array, like this array up here, if I said array 0 plus 3, this is going to give me an error, or this should. Newer versions of Java are smart enough to make it a 0, but just assume that this is going to give you an error, but because it's going to say, hey, you can't change a null value without initializing a value to it first. But yeah, So these are kind of like the two ways that you could work in arrays. Everybody good? Anybody have any questions about array basics? Want to dive deeper? It's pretty straightforward. It's literally just a collection of data.
So with arrays, how would you like, can you just go over how to like, how would you use it in like a specific function?
What do you mean?
Like if you were to put it, like the last assignment, the Mad Libs one, we had to use arrays for like, for the last assignment, the pre-lab, I'd use a for loop to like swap out the words with a, like the person wanted with
Mhm.
like the words the person inputted. And I like, we also, you also put like an array one length.
Okay.
Can you like go over that? Just
Sure.
like,
So why don't we just go over the pre-lab? We have this. We're gonna have our Mad Libs here, which is this array over here that we're gonna create. Mad Libs is equal to, and our little hard code is the blank went to the, and you'll see why I'm doing the spaces like this here in a second. Just for now, roll with it. Went to the blank and asked them for a blank. Right, that's what we got. That's our Mad Libs. And then now we're going to have the user say things and we're going to put them in. There's a few ways you could do it. The way I'm going to do it is, let's actually like think through first. What are the different ways we could do it? One way that we could approach this is directly edit the Mad Libs array at each point. Two, this is a little more creating a bit more future proof. I want to and we'll go both ways later, actually. You know what? For now, I'm just going to edit them directly, okay? I'm going to go, this is the simple way. We'll do the simple. We'll just do the simple way. So I'm going to say, we're going to initialize our scanner, import Java util scanner, and I'm going to create our scanner. Let's see. And over here, and I'm going to say an adjective, right? That's what it was, adjective. And then we'll say mad libs at index 01 is equal to sc.next line. And then we'll say give a noun. And then we go to the next index, which is 2. And 2, 3, 4, 5, because there's 5 of them. Give a place of business 0, 1, 2, 3, 4. And then another adjective. This is 4, 5, 6. And then it's 7 is the second noun. And then we can just do a for loop over it. An enhanced for loop will do mad libs, string through mad libs. And we'll just do system at print. It's the beginning. Or actually, I'll put a space at the start of all of these. I'm just doing a new line at the very end of the loop, at the very end of the program, just for formatting sanity's sake. Okay, so I'm going to go ahead and run this. Nice man factory big dog. The nice man went to the factory and asked them for a big dog. Awesome. This is like just the easiest, quickest, fastest way to do this. Another way that we could do this would be like this. Trying to think. This is one where I would want to use IntelliJ because I want to run it with. Very first time I wrote this program for a demo, I did it using command line arguments. So we actually made use of this, but I don't really feel like getting to that right now. For now, this is the one way to do it. Another way you could do it, I could have a separate array, just so you guys get some visual practice of seeing both types of arrays, both like hard structured and dynamic arrays. What kind of dynamic? I can say responses is equal to new string array, and there's going to be 1, 2, 3, 4, 5 different inputs, right? So what I'll do here is I'll have int x equals 0, and then awesome. Responses at x. I'll say x plus over here. And for those of you curious how I did the multi-line thing, I was holding down Control and I highlighted the lines that I wanted to work on. You could even do just like Control regular click, and it'll put multiple cursors. It's a nice little feature when you're working quickly. Okay, so then what I'm going to do next is I'm going to loop through for int I equals 0, I is less than madlibs.length I plus plus. If madlibs at I equals capital X, over here I gotta reset x equals 0. Madlibs at I, change the value to responses.x at x, and then we'll increment x. And then we'll print it all out. System out print string, and then at the end of it, system out. And if we run it again, it's going to give us, I'll use different nouns this time. The big frog into the shelter, loud dog. The big frog went to the shelter and asked them for a loud dog. Cool. It did the exact same thing. Just this time I had 2 arrays. I decided to, for whatever reason in my design, have 2 arrays. So I would store the user's input here, and then I'd parse through this, and any time that there's an X, I would replace it with whatever. This is kind of a bit more of a dynamic design, I would argue, just because what if, like, let's say I decided instead of madlibs, I change it to, instead of like having a separate array here, I decided to use the arguments. So in the arguments, there'd be like blanks left in, just all manner of different reasons to be able to do this. But I won't get into those too much for now. Both of them are valid ways. There's no one that's like necessarily better than the other, but these are just 2 different ways we could do the assignment. Let's go over some like just demos, general demos of using arrays. Yeah. Let's say, and this is going to kind of relate to your assignment for today. Let's say I want to just generate a random integer. Let's say I want to have let's say max number iterations equal to 75. let's say I want to randomly generate 75 different integers, and then I want to count the number of even integers that I generate. Okay, let's say I want to generate 75 integers, and I'm going to have an integer array. Array is equal to new int array for max number of integers. And what I've done here is I've created a global constant. It's a constant because it has the final keyword, and it's global because it's in the class bracket, it's in the class scope, but it's not in the scope of any specific method, meaning everything can directly access this. Every method within my main can directly access this. If you ever want to call a global directly from your main, which is a static context, you need to make sure you put things in static. And Java will usually remind you of these errors when you try to run it. It'll say can't call non-static blank from static context. What that means is you're calling it directly from within a static method or a static whatever. And if you want to be able to call it directly from a static place, you need to make that thing static as well. For now, we're doing it this way just because it's easier, but eventually, as you get into multiple classes, we're going to wean off of calling things directly, like making everything static. We're going to wean off of that. But for now, it's okay to do. But the reason why you don't normally see it in other programs, normally what'll happen is you'll have like another normally what ends up happening is you say you make a class my class, I'll just call it main, is equal to new main, and then from the main class we'll do run, and this is all like something like this will be all that your main method will have. It'll just do whatever part of your program needs to be called to start up the whole program, and that's it. That way you don't have to worry about the whole static thing. But because we haven't really gotten into classes and instancing, we're not going to do that yet. But so yeah, we'll do. So don't worry too much about that. That was just kind of a tangent. Int array is equal to new int array of size max number of integers. So what's this final keyword mean? Final means that this thing cannot be changed, that this value that we assign cannot be changed. It's a constant. It's always going to stay that way. The common naming convention is to do it like this, capital letters with underscores for the spaces. It's not going to break your program if you don't do that. You can make finals that don't have this. You're not going to get an error from, you're not going to get like a compilation error or anything, but it's the standard naming convention that people use. So it's good practice to do it. Anyways, then what we're going to do is for int I equals 0, I is less than max number of integers, I plus plus. For each one, we are going to put a array at I is equal to new random dot next int. We're going to put a random integer between, let's say, we'll put another limit here. Static final int max value is equal to 400, just say. So right now what this method's going to do is it's going to create a new random integer between 0 and max value minus 1, so between 0 and 399. It's going to create a random integer between those. It's going to add it here. So we're going to go ahead and run this. And in fact, just to kind of get you guys thinking for the assignment, static int populate array. Here. Turn array. equal to populate array. I'll just say new int max number of integers. Okay, so I just want to run this first, make sure I don't get any errors. Then I'll talk about the code that I just wrote. Cool. So this is one of those things of you guys may want to do this in multiple steps on your end, but because I'm used to just writing code like this, just reducing what I consider redundant steps. To me, having like declaring a new empty int here and then saying empty array here and then saying array is equal to populate array, doing like that, to me that's redundant. Why do that when I can just do it in one swoop? So I create a new array here, and I want to populate that array with this. I've just created out of thin air a new integer array that has this many slots, and this is exactly the argument that it's expecting. Goes through this new int array of max number of ints of 75 slots, populates each of these 75 slots with a random integer between 0 and 399, and then returns that. Then what I'm going to do, int num evens equals 0 for int number in array if, this is how we, this is the Boolean expression for checking if something is even. If it's even, then I'm just going to increment the number of evens variable, and then when we're done, ln. Actually, I'll do it as a printf, just so you guys get some practice of seeing that. Of the integer placeholder, ints in the array ranging from 0 to another integer placeholder in the array. There were integer placeholder even numbers. We have to put a new line at the end of it because printf doesn't do that on its own. And then the first one of the max number of ints, that'll be the integer for the first %i. Then for the next %i, it's going to be max value minus 1. And then there were num evens, even numbers. So if we run this, exception and thread, unknown conversion. Oh, D. I guess it's D. It's different in certain languages, and for instance, in C, it's a %i. In other languages, it's %d. It just varies. Yeah, here we go. Of the 75 integers ranging from 0 to 399, in the array, there were 41 even numbers. Right? Awesome. Cool. We have a little program now. It creates an array of whatever size we define it to be here. And then it goes through and populates that with a bunch of random integers ranging from 0 to whatever the max value minus 1 is. And then it returns that array over here. So now we have this populated array. And then we go through that array over here. And for each time we encounter an even number, we increment the number of evens counter. And at the very end, we just print everything out. Cool little demo using arrays in a similar way to what you guys will be doing today or this week for your lab. So I guess let's talk a little bit about that. So for the Dice Stats lab, for those of you who might be familiar with any kind of role-playing game system, like tabletop role-playing, or, you know, I'm sure you've seen in pop culture people playing like D&D and stuff, they use these little polyhedral dice. You know, there's different kinds. And I've listed them all here. There's a D4, which is a 4-sided dice, a D6, which is a 6-sided dice, so on and so forth. You guys get the picture. You guys have to do a few things. One, you have to create a method that will roll these dice. Keep in mind, when you're doing this, you can use math.random, you can use random.nextInt. Whichever library you want to use is totally up to you, but make sure you read the documentation for whichever one you implement, because usually there's some conditions. You have to know what outputs expect, know how they work, and most importantly, be aware of the fact that they're not inclusive. So when you provide a max value, it prints out numbers from 0 to your max minus 1, not to your actual max. It's usually not max inclusive. It's base inclusive, but not max inclusive. But this will be up to you guys to read the documentation a little bit for Java, understand what these methods do, how they work, what inputs they need, what outputs they give, how they do it. And the documentation baseline does a really good job of explaining it. Then there's websites like, Tutorial Point, Geeks for Geeks, W3 Schools, all these different websites that go and break it down with examples of how these work. So there's a plethora of information out there. Look for it. If you guys have questions or you're not understanding what you're seeing, as always, you can ping me on the Discord, ask in the homework help section of the Discord. You have all these tools available. I really want to encourage you guys to get used to searching for this information on your own, because the sooner you get better at this, the easier the harder classes for CS are going to be. Anyways, first step is you're going to create arrays. You're going to create a way to store data. The purpose of this lab is you're going to roll each of these different kinds of dice 10,000 times, and this 10,000 times should be stored in a global constant variable. Such should be a final. You're going to roll 10,000 times, and for each different kind of dice, and you're going to record those somewhere. Once when you've rolled each of the 6 different kinds of dice 10,000 times and stored all the outputs for those, for each of those dice types, you're going to calculate the average or the mean, and then the standard deviation. And there's formulas for that over here of how to do it. I think the Java math library might even have stuff that does this for you. I would prefer for you guys to calculate it yourself. I will be looking in your code. If you use like math.average, math.standard deviation, stuff like that, I will take points off, because I want you guys to actually write your own implementation of it. It's not too hard to do, and I think you guys have the tools now to do it. The way standard deviation works, here's the equation for it. If you're not too sure what this equation means, you get a sum value. This sum for each term that you're going to add, you go through your list, you take the xi, which is whichever element in your array, subtract it from the calculated average of that list, square it, and then you do that for each term in the list, and you add them all together. Once when you have this sum, you divide it by the size of the list minus 1, and then you square root the whole thing to get your standard deviation. For those of you that might be curious what standard deviation is, it's a statistical, it's basically a statistic to calculate how different each element in a list is from the other. That's the long and short of it. Anyways, once when you have that, you're going to display your results. You're going to show what your calculated average was for each dice type, what the calculated standard deviation was. Then you're going to calculate the percent error for each. Percent error basically shows how far off you are from this theoretical average. So each dice has an average roll, meaning if you roll a d4 many times, on average, it's going to be a 2 or a 3 is what this number means. There's going to be an equal number of 2s and an equal number of 3s over infinitely many rolls. So that tells you where the dice tends to land. And you're just going to and there's instructions on there how to compare, and you can kind of look at the output as well. As you guys can see, for the expected practical average, there's the expected average as a decimal number. Then there's what I've called the practical average. That's where you round it down, because the dice will never land on a half, right? It will always be a full value, so you round it down. And then just for funsies, you use your practical calculated average, which is your calculated average rounded down, and your expected practical average, which is the theoretical average rounded down. And then you do a percent error based off of that. I know that was a percent error is wrong. Percent error equation. The accepted value, the theoretical minus the experimental. Nope. It's the theoretical minus the experimental over the theoretical. Or, yeah, right? Accepted value, yeah, over the theoretical. So yeah, that was wrong. It's theoretical minus experimental over theoretical. So thank you, Jimmy. All right. Oh, and keep in mind, this is an absolute value, which means you don't care about the negatives. That was a kind of a lot to go over. I know this looks daunting at first, but I encourage you guys to just sit down with a pen and paper and just think about each individual step. Just really break this thing down to its components, right? I do this a lot with any project that I'm working on. I try to like just draw out what are the basic things that I have to do. You know, if we go back to the whiteboard, you know, what are the things we have to do? Well, one, we have to have a roll method that's going to take some value, and based on this value, it's going to roll. It's going to give out it's going to output an integer 1 to x, with x inclusive. Then we're going to take this output and we're going to stick it into an array. I'll call it D4, for instance, right? And then we'll have this for a D6, a D8, etc. And we're going to do this 10,000 times for each array. We're going to roll 10,000 times for each array, so for a total of 60,000 times. We'll have generated 60,000 data points. And then for each array, we want to calculate the x bar, which is the mean, and then the sigma, which is the standard deviation. And then we're going to compare this to the theoretical. We'll call this squiggly x is a theoretical. We'll compare it to that, and we're going to output those results. This is essentially what this whole program is going to be doing. Any questions about that? Even though this assignment is simple, because it's like the first one that's very like the most practical of assignments you've done thus far, because the first really practical one, students tend to get very confused about what they're doing. Does anyone have questions about what it is you're trying to accomplish with this program? The best way to think of it is it's like a physics lab. You know, if you're taking physics 1 right now, that lab you have where you have to test the acceleration due to gravity, minus 9.8 meters per second squared. The way you do that, you have 2 photo gates, you drop an object in between, and the photo gates will measure, you'll know the distance between the photo gates, you'll measure the time it took to go from 1 to the second, the speed it had going, and then you'll calculate its velocity based off the measurements of the distance and the time, and then from there you'll also calculate the acceleration of it due to gravity using kinematics equations. You're doing something very similar here, except with statistics instead of physics. Any questions at all about what you guys are doing for this assignment? Any questions for milestone 1?
So milestone 1, you want us to like make like a combat loop, right?
That's all you need to have.
Are there like, is there anything we should like look out for, or anything you were specifically looking for with the combat loop?
I want you to implement as much of your basic combat as you can. It should be just like a demo of your combat, right? So you can have one monster, multiple monsters that you fight, whatever, however you want to do it. I don't care. But effectively what I want to see is I want to boot up your game. I want to boot up your program, and it's going to tell me, hey, you've encountered a monster. You have this much health. Monster has this much health. Or, you know, keep the monster health hidden. I don't care. But the player should know how much health they have. And they're going to choose actions, and it's going to keep updating them at each round. Like, hey, here's what happened this round. Here's your health. Monster did this, etc. And keep updating that. And it's going to keep going until the monster or the player dies. And then at the end, it's going to announce you died or the monster died. and the program
Okay.
is over.
So another thing, so what if like let's say your combat loop, what if your like combat loop like at least with mine, you go into a specific room and there'll be a monster there.
Mm-hmm.
And then do you want to just do that part like going into separate rooms?
Just that part. No exploration at all. Just the combat.
Just
Just that isolated part of the game.
okay. Got it.
Mm-hmm. I mean, if you want to, you don't have to. I'm having trouble with the milestone with the turn-based idea. Okay. Let's go over a little demo to help with the turn-based thing, because this is one where students struggle a lot. The easiest way that I can do it, that I can explain it, is the easiest way you can do it is have one player, one monster for this demo, just that purpose. Have it like that. And then what you could do, you could have an int round start at 0, and then just say I'm gonna write like a very. I do not want you to write your combat loops like this. This is like purposefully the wrong way to do it. But monster HP is 5, player HP is equal to 5. And damage, each time they do damage is going to be 1. All right, I'll just hard code that in. While monster HP greater than 0 and player HP greater than 0. If round is even, then it's going to be the player's turn. Else, this part you could use, and then at the end of each loop iteration, we're going to say round plus plus. We're going to go up a round, right? Here's kind of like the body of the combat loop. You're going to handle the player's turn in here. You're going to handle the monster's turn in here. So here I'll say send out LM, player hits the monster. And then monster HP minus equals 1. I'll say monster hits the player. And at the end of the game, we'll say if monster HP less than or equal to 0, player wins. Otherwise, player is dead. Oh, I'm forgetting my semicolons. So obviously this is bad because there's no interactivity at all. This one. Obviously this is bad because there's no interactivity at all. But it'll say, player turn, player hits monster, monster hits player, player hits monster, monster hits player. At the very end, player wins, right? This just is a very simple loop, goes from one to the other, one to the other, one to the other. But this should be how, this is a very easy way to implement the 2 players' turns. Is just using an integer counter. There's other ways you could do it too, especially if you have multiple monsters. This will only work for 1 player, 1 monster. There might be encounters in your game where you fight multiple enemies. There might be 1 player fighting 2 monsters, or maybe like the player has a party of 2 different heroes that they could control. And it's going to change depending on the round. There's so many ways you could do this. You could take the number of however many players or monsters you have, put them in an array, and then depending on just keep looping through the array 1 2 3 4 1 2 3 4 1 2, or like however many, keep looping through that array, and that array will dictate whose turn it is. There's so many ways you could do this. Also, you can add types of combat the player can use. Yeah, like this is bad because it's not a game, it's a simulation. For your game, the player should have options on their turn of what they do. There should be some thinking going on the monster's part. The monster, I would like to see the monster have more than 1 attack, more than just like a basic attack. Maybe the monster has a special attack that they use if their health is low, right? Maybe they can only use this once. Like just think about some of the stuff to put in to make it a little more interesting. Ultimately, you're trying to create a good game, right? That should be the end goal for this. You're trying to create a game that's going to be fun, or at least enjoyable. Any other questions about this? Okay. If there's not really any other questions, then I don't really have anything else for the day. I'll be available in the Discord. Just ping me on there if you guys have questions, and I'll get back to you. But for the most part, you guys have been pretty good about helping each other out. So the Discord link, I'll put it in. I'll put it into the chat. There. When you get in, just make sure you select the role for whichever class you're in. And there's instructions in there added to that. That way you unlock the whole Discord. All right. Have a good weekend, everybody.